sklearn, utils, metadata routing, method mapping. Description. This class serves as a decorator for functions within sklearn. It helps manage the metadata associated with methods, allowing for standardized processing and information sharing across the library. Inputs. Function. The function that the decorator is applied to. It should typically be a method of a sklearn class. Quags. Additional keyword arguments passed to the quags method. These arguments are used to set up the metadata for the function. Outputs. Decorated function. The original function decorated with metadata management capabilities. Steps. Initialization. When the decorated function is called, the quags method is called with the provided keyword arguments. This method sets up the function's metadata, including the input and output types, the function's role in the sklearn pipeline, and other relevant information. Execution. The original function is then executed. Metadata management during function execution. The checkquags method checks if the function's input arguments are compatible with the specified metadata. It also ensures that the function's output matches the declared metadata. Metadata propagation. The decorated function may modify its metadata during execution. For example, to indicate changes in the input or output types. This metadata is then automatically propagated to the next stage of the sklearn pipeline. Metrics. Execution time. The time taken to execute the function. Visualization. Plots. Flowchart. A visualization of the function's place in the sklearn pipeline, illustrating the flow of data and metadata. Parameter space. A visualization of the function's parameters and their potential impact on pay. Output. Fine-tune parameters. Input type. A string specifying the expected input type of the function. For example, array like data frame or series. Output type. A string specifying the expected output type of the function. Role. A string describing the function's role in the sklearn pipeline, such as transformer, estimator, or scorer. Uncertainty methods. Confidence intervals. Estimating the uncertainty in the function's output using statistical methods. Challenges and fixes. Challenge 1. Ensuring that the metadata is consistently maintained across all sklearn components. Sample use case that resulted in challenge 1. A function may unintentionally modify its metadata, leading to inconsistencies in the pipeline. Fixes to challenge 1. The checkquags method helps ensure metadata consistency. Challenge 2. Managing metadata complexity for functions with multiple inputs and outputs. Sample use case that resulted in challenge 2. A function may have complex input and output types that are difficult to represent with simple metadata. Fixes to challenge 2. The quags method allows for flexible and expressive metadata configuration.